Hello friends, today we are going to discuss about the first type of problem which actually come from signal flow graph problems, and the first type is the normal type which actually not come in the exams, and a signal flow graph is given, and from that signal flow graph we have to find out the transfer function. In my previous video, there I described the Mason's gain formula, and there were some part and related to delta, but the delta part is actually tough to understand if you don't see any example about that. So here the first example and the first type of problem which comes from a signal flow graph, and this is just like this. And now the solution of this is very simple. First of all, you can see that the gain of individual path is given here. If that is a forward path, here it will be forward path. If that is a forward path or there is a feedback, there the gains are written previously. Now from that gain value, each and every gain value, we have to find out the transfer function of the system. Now first of all, let me write the Mason's gain formula, because from that it will be easy to understand that what to do step by step. So Mason's gain formula tells us that transfer function is equal to summation k pk delta k by delta. K is the number of forward path. Hence, from this formula we can calculate the overall transfer function of this given system. Means we can find out the output by input ratio from this formula. So first of all, let us write the number of transfer function, so number of forward paths, that is k is equal to number of forward paths. So let's see that how many forward paths are here in this signal flow graph. So it actually starts from here, the x1 point, then x2 point, x3 point, x4 point, and x5. These are actually the nodes. If it comes from a block diagram representation, then these nodes will be nothing but the takeoff point or the adder or the summer. Okay. So here the forward path is the path from the input to output. Means from this path we can reach input to output. Means this is a forward path. Now another forward path we can see from here. It is also reaching from input to output, but in another, every path we can't reach the output. It is like a feedback, like a backward path, feedback, and this is also a loop. Hence there are two forward paths. Now let's write the number of forward path value, that is k is equal to 2. Now pk is the kth forward path gain. Means here forward path gain means p1, the first forward path gain, p1 will be, actually it is the multiplied value of individual gain of each path, that is x1 to x2 a12, x2 to x3 a23, x3 to x4 a34, and we have to multiply them. Hence the forward path gain, first forward path gain will be a12 into a23 into a34 into a45. Very simple to calculate. This is very simple to calculate. Now there are two forward paths actually, so the second forward path gain, that is p2, is equal to second forward path. Now this becomes very, that is a12 into a23 and only now a35. Now pk calculation is done, but now to find the delta value, I have told that delta is equal to 1 minus summation of all the loop gains minus summation of or sum of product of two non-touching loops minus sum of product of three non-touching loops and so on. So to find out delta, to find out delta, we first have to calculate the number of loops, that is how many loops are there in this cycle. So if we see the diagram, there is actually 5 loops, and this calculation or this understanding is very important to solve any signal flow graph. And this is actually the key point. If you don't understand or don't recognize how many loops are there, the total transfer function equation or the expression will be wrong. So we can see that here this path forms a loop, that is, this is the first loop, this is the second loop, this is the third loop, and here two more loops, they are here. And this is very important, that if you go this way, then it also completes a loop, though it does not look like a circle or semicircle, but it is a loop, it is a complete loop. For you have to understand this very clearly. You have to see the signal flow graph once or twice, several times, many times. You have to need to see the signal flow graph to understand how many loops are there. So this is very important. So we have found out 4 loops. Now the fourth loop and the last loop is this path. Here it goes forward and backward. So we have got all total 5 loops. We just have to multiply the gain values and find out the loop gain values. So here the first loop gain, that is this loop, the loop gain is a23 into a32, a23 into a32. This is the first loop gain. The second loop gain, that is a23 a34 into a42, a23 a34 a42. The third loop, it is obviously loop, so this loop is only consisting of this gain a44, that is completing in a single node. So this loop gain will be a44. Now the fourth loop gain, that is a45, 2 3 3 4 4 5 5 2. A 2 3 A 3 4 A 4 5 A 5 2. And the last loop gain is A 2 3 A 3 5 A 5 2. Let me write this all. A 2 3 A 3 5 A 5 2. Hence the all 5 loops gains we have calculated. Now to find out delta, we also have to calculate the number of two non-touching loops and 3 non-touching loops. If you see the signal flow graph properly, you can see that this loop and this loop are not touching each other, means these two loops are non-touching, so this will be called two non-touching loops. This is a pair. Another pair, we can see this loop and this loop, they are not touching each other, means this is also one pair of non-touching loops. Hence there are two pairs of two non-touching loops, and we can't find any other two non-touching loops or three non-touching loops, means the value of the other parts will be 0, and there will be only two non-touching loop pairs, and that will be considered in the delta value calculation. Means here the number of two non-touching pair is 2. So let me calculate that. Let me take it one as L11, another one is L12, or you can take it as L22. So first sum of product, and this will be the sum of product, means we first have to multiply them, means the multiplied version of non-touching loops. So first loop is A23 A32, and this will be multiplied with A44. So L11 value will be A23 A32 A44, and L22, the second pair, the summation of their gain will be A23 A35 A52 and then A44. Very easy. This part was very hard to explain in the Mason's gain formula without any example, so this is very clear now to you that how these parts comes, and it will be very easier with many problems. If you practice more problems, this part will be very clear and easy to you. And Mason's gain formula calculation is very easy. From here you can easily find out any transfer function of any kind of system, and you can calculate it more faster. So the last, this multiplication or the product will be A23 A35 A52 and A44. So now the delta value, which is actually the characteristic function or the signal flow graph determinant, characteristic function, that will be 1 minus L1 plus L2 plus L3 plus L4 plus L5 minus sum of these two products, means L11 plus L22, and there is no any other two non-touching loops, hence rest will be no value, and there is no three non-touching loops, there is no three non-touching loops. Oh, this will be actually plus and this will be minus. Then one more time. This is correct. 1 minus, this will be plus, and the three non-touching loops, that will be minus, but this will actually 0 because there is no any three non-touching loop combination. We did not get that. Hence the value will be 0. So this is actually 1 minus L1 plus L2 plus L3 plus L4 plus L5 plus L11 plus L22. So delta value is calculated. So let me mark it as equation 1. Now the one more part, that is the delta k. So the delta k I have described in my previous video, but here you can understand it very clearly that what delta k is. Delta k is actually the part which is not touching kth forward path. Means for the first forward path, for the first forward path, delta 1 value will be 1 minus the part which is not touching, or the loop which is not touching the forward path. That is, every loop is touching. Every loop is touching means here the value will be 1 minus 0. And delta 2, as k's value is 1 and 2, so 1 and 2, delta 2 value is second forward path is not touching with which loop. We have to understand that is, this forward path is not touching this loop only and touching all other loops. Means here the value of delta 2 will be 1 minus A44. This value, this part is very important, and always remember how these are calculated. So now every necessary part is calculated. Now just put them into the Mason's-Gain parabola and you'll get the transfer function. Hence finally the calculated transfer function will be, I am writing the equation here, that is summation k pk delta k by delta. Here the value of k is 2, hence pk delta k by delta is equal to p1 delta 1 plus p2 delta 2 by delta. So we have calculated the value of p1 previously, so let me put the values here. P1 value was a12, a23, a34, a45 into the delta 1 value, that was only 1, plus P2 delta 2. P2 was a12, a23, a35 into delta 2 we have calculated, that is 1 minus a44. 1 minus a44. Now by delta value we have calculated 1 minus L1 plus L2 plus L3 plus L4 plus L5 plus L11 plus L22. That is, we can substitute all the values calculated previously, and finally the transfer function will come like this: plus a12, a23, a35 into 1 minus a44 by 1 minus L1 was a23, a32 plus a23, a34, a42 plus a44 plus a23, A34, A45, A52, and L5 was A22, A35, A52 plus L11 minus L22. Those were A23, A32, A44 plus A52, that is L2. This is actually L22, A52, A23, A35, A44. So we can simplify this. We can this comes actually very large, so we can simplify this and get the transfer function. And this is actually the procedure which I tried to explain you, and this is the basic of any signal flow graph, and in this way you can find out any transfer function of any system from signal flow graph very easily. So this was the first type of problem from signal flow graph, and the second and the next three types I will be explaining in my consecutive videos. And stay tuned and subscribe my channel, and if you like it, press the like button and comment below if you have any query about it, and I'll be solving the next type of problems in my next videos. So thank you.